like, so you have a selectively permeable membrane, right?
Right.
And solution on both sides. If you have a highly concentrated solution on one side, water is going to want to flow which way?
Well, the solution will want to go to the right, right? All the particles. The water will want to go in.
Yeah.
Yeah.
Water will go this way. Because let's say that this membrane won't let the particles pass through, but it'll freely let water through.
Right.
And so water goes towards the higher concentration, right? Okay, so what is this showing? Okay. So what osmotic pressure is basically, because when the water is flowing this way, the water is going to go up this way, right?
Right.
And it's going to create more pressure kind of pushing downwards and against this membrane, right?
Right.
So eventually the water will stop going this way because the pressure being built up by this water is stopping the water from coming back in. Does that make sense? So osmotic pressure is the resistance of osmosis, right?
Right.
Because let's say like initially we had, the water was like right here. Eventually this water would flow in here, but then there's going to be pressure against this water passing through that membrane, right? And sometimes they call it hydrostatic pressure. And it's kind of a similar thing when we're talking about, because this filtration happens at the capillaries, where water is going out of the capillaries and back in and stuff like that. So this kind of determines how much water will pass through. So let's see. So at equilibrium, when the water stops passing through, it says that, which means that the movement water. Okay. So is the force required to prevent water from moving across? Okay. The greater the concentration of the solution, the greater tendency for water to move into the solution and the greater the osmotic pressure to prevent that movement. Oh, okay. Yep.
So is the osmotic pressure something like I'd have to know percentages or calculate, or is it just kind of a...
No, it's like a principle type
Right.
thing because, they'll give you...
So obviously the higher the solution, the more pressure there's going to be because more water will flow in.
Yeah.
Okay.
And also, the more concentrated the solution is, the more easily the water will pass through, right?
Right.
So, like the more concentrated this is, the more water it'll be able to pull into this area, so the greater osmotic pressure that it can create.
Right.
In the end. So.
But eventually it's going to reach a cap, right?
Yeah. Mm-hmm. Yeah, there's going to be a equilibrium, and but yeah, you probably won't get into like numbers of pressures because it's difficult because they measure. Usually they measure they measure an osmolarity, which is a concentration, it's not a pressure. Does that make sense?
Yeah.
So, for example, like your blood is like 260 milliosmoles per liter. And that's like the concentration of solutes in your blood. But it doesn't tell you what your blood pressure is, because it's really, the pressure is relative to the concentration on one side and the other side, right?
Right.
And so, I don't know, it's kind of more of the principle behind it, and they probably will ask you to calculate it, because it doesn't give you a equation in here anywhere, so.